Hi everyone, welcome to today's tutorial. Today we're going to treat balancing of ionic equations. In our previous lecture, we have discussed electrochemical cells and redox reactions. So let us summarize what we did on redox reaction. We said that redox reaction represents two reactions. One is reduction, the other one is called oxidation reaction. Reduction is electron gain, whereas oxidation is electron loss. These two reactions are complementary. They occur simultaneously at the same time in a chemical reaction. And this reaction is also known to occur during electrochemical processes. So in a electrochemical cell, we have two half cells, the oxidation half cell and reduction half cell. So to get the full cell of what is taking place in a chemical cell, we'll add the reduction equation to the oxidation equation. Okay, not to worry, we shall still come to that point. Now we're treating ionic equations today. We're treating how to balance ionic equations. So before we go on to this, ionic equations are equations that show the ions participating in a chemical reaction. And these ions, this equation will show the reduced substance and the oxidized substance. For instance, we may have this substance. This is an ion reacting with another substance. On the day, we have M and then Z positive. This is an ionic equation. In this reaction, the substance M has oxidation state of N, going from N to plus N to 0. That means the substance M positive charge has been reduced from 2N to 0, while the substance Z has this state increasing from 0 to plus N. So in this reaction, this substance has been reduced because the oxidation state has decreased from whatever plus N is to 0. So this M is now called the reduced species or the oxidizing agent or reduced species. Whereas Z has its number increased from 0 to positive N. That means that Z is the oxidized species or oxidized substance, and that Z is called the reducing agent. So I come again. This is a hypothetical example of two substances that are reacting in ionic equation. M is an oxidation state of plus N, and then during the reaction, M moves from positive N value, oxidation state of plus N, to 0. In chemistry, whenever an element is on its own, we take neutral, that is a neutral element, we take its oxidation state as 0. So it's moving from positive N to 0. That means the value of the state has decreased. So we now say that N has been reduced, has undergone reduction, which is decreased oxidation state. And any reduced substance in chemistry is called the oxidizing agent. Then looking at Z, Z has moved from 0 to positive N, increment. Any substance whose oxidation number increases in the positive direction is said to be the oxidized substance, oxidized species, or reducing agent. How to understand the concept of oxidizing agent and reducing agent? Let's think of two people in a relationship. For instance, we have Anthony, relationship with Jane. Then Anthony has $3,000 with him, while Jane has a hoping sum of 50,000 US. So going to visit her boyfriend, she goes with this money in her pocket, hidden in her pocket. On reaching Anthony's house, Anthony now gives Jane 2,500 out of the 3,000. So at the end of the process, Jane now has $52,500, while Anthony has remaining $500 to wallow in poverty. Now in this situation now, Anthony has hostilized Jen by giving Jen part of his money, even though Jen has none. So Anthony giving Jen money makes Anthony reduce. So the other agent in the substance that he reduce, the value must decrease as you move across the product side. So Anthony is the oxidizing agent or the reduced substance because his money has decreased afterwards. While Jen, that accepted some money from Anthony, became oxidized, lifted higher. She has come to reduce Anthony to nothing. Her money has increased to $2,500. So if you look at this situation now, that Z stands for Jen because her money has increased from 0 to N positive. So the reducing agent is the substance whose value decreases. The reducing agent, reduced species, is the substance whose this number now stands for amount, whose amount or money decreases, and we call that the oxidizing agent, reduced substance. While the oxidized substance species is the reducing agent, in this case, the Jen reducing agent, Anthony is the oxidizing agent or reduced person. So having understood this concept of reduction, reducing agent and oxidizing agent, we now look at the steps involved in balancing ionic equation. What steps are involved when we want to balance ionic equation? The first step, we have some procedure that will help us as guideline, is 1. Identify the reduced substance, otherwise called the oxidizing agent, and the oxidized substance, otherwise known as the reducing agent. When we have done that, then break the ionic equation into 2 half cells. Break it into 2 half cells, namely oxidation and reduction half cell equations. Then the third step is write the oxidation half cell equation with the reducing agent, which is of course the oxidized substance. Then the fourth step, write the reduction half cell equation with the oxidizing agent, which is reduced species. Then the fourth or fifth step is add both half cell equations and eliminate the electrons. So if you follow these steps religiously, you're going to get your answer. So to balance ionic equation, first of all, you have to critically examine the ionic equation and identify the reduced substance, that the substance whose oxidation number decreases, which is normally called the oxidant agent, and also the oxidized substance reducing agent. Break the ionic equation into 2. You're going to have the oxidation half cell showing oxidation taking place, and reduction half cell showing reduction taking place. Then write the oxidation half cell, write the reduction half cell, and then add these 2 processes together, getting the electrons. We're now going to take an instance. For this question, we are asked to balance this ionic equation. So looking at this equation, the first step says identify the reduced substance and the oxidized substance. Look at this very well. Let's start with aluminium. The oxidation state of aluminium here is 0. In chemistry, element in its neutral state or uncombined state will take its oxidation number as 0. While here it is plus 3. That means the oxidation number of aluminium increase. That means aluminium is the oxidized substance or reducing agent, because its number increased from 0 to plus 3. Now looking at zinc, the total of zinc on this side is 2, while the percentage of zinc is 2 here, as you can see. Then here is in neutral state, it is 0. So we see that the state of zinc has decreased from plus 2 to 0, meaning that zinc is the reduced substance or reduced species. And reduced substance is called the oxidizing agent. So, having done that, we now go to the equation. We have done the first step, identify the reduced substance and oxidized substance. The next step is to break this equation into two parts. Break it into oxidation and reduction equation. Okay? So we now see that this one has undergone oxidation. We bring aluminium and this. We now have aluminium giving us aluminium 3. This is the oxidation house cell using the reducing agent to write it as we specified there. So the right oxidation house cell equals with the reducing agent. And then, okay, let us now write it before we go to step 3. Oxidation in chemistry is electron loss. Now, electron loss. For aluminium to move from 0 to 3, it must have lost electron. That is the definition of oxidation. So we're going to put this in form of equation. This is the reactant, while this is the product. So bring in electron, negative, minus, loss. This will signify loss. E. The symbol E minus is the symbol of electron, redox reaction. We now write S in front, meaning the number of moles of electron lost in the equation, giving us aluminium 3. Before we continue, we need to balance the equation. Find what S represents. This is now a half cell equation showing oxidation. So what do we do? The state of aluminium here is 0, being in its neutral state or uncombined state. We add the charges. Before we add the charges, the first thing we have to do is to make sure the atoms are balanced. So the atoms, one atom of aluminium here, one atom there. So the atoms are balanced. We now move to the electron. So add the charges 0 here on aluminium. The operation sign here is minus. On electron also minus 1 multiplied by S, the number of moles in front, equal to the charge here is 3. So we now have 0 plus S equal to 3. That means S gives us 3. So the equation becomes Al minus 3E, giving us Al3 plus. Then we know in chemistry the convention is when you write an oxidation half cell equation, the electron is carried over to the product side, or electron is released, so it's given out. So we now have taking this as equality time and carry electron to the other side, we have Al3 plus 3E. We call this equation 1. So this shows oxidation, of course. Aluminium goes from 0 to plus 3. Then we have done the second step. The third step is write the oxidation half cell. Okay, error here. Okay, the first one we wrote this is oxidation half cell that we wrote. So we should be going to writing of the reduction half cell. So this is oxidation half cell. So this we should go into reduction half cell now. So reduction, if we go back to the zinc, is reduced from 2 to 0. By reducing reduced substance, we're using the reduced substance in this case now, corrected. So this is going from 2 to 0. We now take zinc, moving from plus 2 to ordinary zinc. This is reduction. Why is it reduction? Reduction is gain of electron, of course, and also decrease in oxidation number. Zinc is going from 2 to state of 0. Is a neutral state here, so this is reduction. We're going to now use it to formulate the reduction equation, we now have zinc 2 plus electron gain, because reduction is electron gain, while reduction is electron loss, giving us zinc on the other side. So we have to find how many moles of electron are involved here by first of all checking that the atoms are balanced. One atom of zinc here, one atom of zinc over there. We now balance the electron. To balance the electron, we now add the charges. The charge here is 2. The operation sign here is now plus, not minus. Then the electron charge is minus 1 times S, which is S moles of electron, giving us the charge here is 0 because this is a neutral element. So you have 2 minus S 0. Then minus L is equal to minus 2. Minus cancels minus. So the result equation will be zinc 2 ion given plus 2E. That's replacing S with 2, which we obtain here. So this is equation 2 now. Oxidation equation and reduction equation. Oxidation half cell from 0 to plus 3, reduction from 2 to 0. We are trying to balance this equation here. Then the next fifth step is to add the two half cells. So how do we go about adding the two half cells and eliminating the electrons? So we have Al breaking down the oxidation half cell up there. Reduction half cell zinc 2 plus 2 electrons giving us zinc from 2 to 0. Want to add them, we'll draw a line under. Before we add them, we'll have to cancel the electrons. The electrons are not equal. If there were, we have 2 electrons here and 2 there, or 3 will cancel. But this is on the right hand side, one on the product side. But because they are not equal, we can't cancel like that. So what do we do? We multiply this first equation by the electron coefficient here, which is 2. Multiply this second equation by electron coefficient over there, which is 3, to make the electrons equal and eliminate them. When we do that, we'll be having what I will multiply. We'll multiply the number of moles in front of the substances. We have 2Al giving us 2Al3 plus 6 electrons. Then 2 zinc 2 ion 2 moles plus 6 electrons giving us, sorry, this is 3 now. 3 zinc 2 ion in front, 3 times 2 is 6. Then 1 here is 3 zinc. Repeat myself. 2 times the number of moles here is 2. 1 here times 2 is also 2. 2 times 3 is 6. 2, 6. So 3 times 1 in front is 2, 3. 3 times 2 is 6. 3 times 1 in front will give us 3. So what we'll do? We'll now add them. Electrons are not equal. We cancel out the electrons and add the reactants. We have 2Al plus 3 zinc 2 ion, giving us 2Al3, that's the product, plus 3 zinc. Adding the reactants on the left hand side and adding the products on the, this is now the balanced equation. Look at it very well. It's that zinc has 2 atoms on the left hand side and also 2 atoms on the right hand side, product side. So aluminium has 2 atoms, sorry, and then 2 on this side. Zinc has 3 atoms on the left hand side and 3 on this side. Checking the charges, there are no charge on this, 0. The charge here is 3 times 2, 6. That means the reactant has the charge of 6. The charge here, there are no charge here. This one will be 2 times 3 also, 2 times 3 also 6. We have equal charges and equal atoms on both sides. That means we have a balanced ionic equation. Then we take another example on this. We are given this question. And the question says that both reaction occurred in an acidic medium. Balance the equation. Okay? So how do we solve this problem? The same processes or steps are listed before. So if we examine the reaction, we see that something appears to be wrong. Because oxygen is on this side and we're not seeing any oxygen on the other side. So where has oxygen gone to? So we have to read the equation and be able to find out what happened to the oxygen. We are told that the reaction occurred in acidic medium. So an acid is not indicated here. So the presence of acid is indicated by writing hydrogen ion. According to Ionic's theory, an acid ionizes to produce hydrogen ion in aqueous solution. So we're going to bring this one to represent the acid. So giving us Fe3 plus chromium, then 3 ion, and then water, because the hydrogen ion now will take oxygen and form water. So we now have the complete version of the equation. Then we'll now start. First of all, we're going to find the oxidized species, oxidized substance, or reducing agent. To start with that one to make it easier for us. So to find the oxidized substance here, a close inspection, you see that the one oxidized is ion 2 ion, because ion 2 state here is plus 2 and the state here is plus 3. Oxidation is the increase in oxidation number. So this is the oxidized substance, or we can as well call it the reducing agent from our discussion earlier on this lecture. You see that ion has gone from 2 to 3. An ion can only produce iron. Ion cannot produce chromium. An ion cannot produce water. So having done that, we now write Fe2 giving us Fe3. So what's oxidation? We're going to write the Ionic equation. Oxidation is electron loss, as we said. So we're going to subtract electron from ion 2 to give you ion 3. So how do we go about it? Now write Fe2 minus S moles of electron, giving us Fe3. So this is the oxidation half cell equation. So we're going to find what S represents. To find S, we add the charges on both sides of the equation. We now have 2. Before we add, we make sure that the atoms are balanced here. That's the first step. Atom here is we have only one atom here and one atom ion there. That is good. One of ion here and one over there. Ion is balanced. The element is balanced. Now look for the electron. Don't ever make the mistake of going to balance the electron when the atoms are not balanced. Make sure the atom is balanced, or the atoms, more than one atom, are balanced before you talk about the electron. So we now add the charge. The charge here is 2 for ion 2. The operation side here is minus. Here is S times minus 1 equal to the charge here is 3. Then I have 2 plus S giving us 3. S gives us 3 minus, which is 1. That means one more of electron was lost by ion 2 to produce ion 3 ion. So the oxidation equation becomes Fe2 ion minus E, which is 1 mole here, giving us Fe3 ion. Good. Having done that, we're now going to put, as I say, the convention is to during oxidation is to transfer electron to the product side. We now have Fe2 giving us Fe3 plus electron. So we call this equation 1. This shows the oxidation equation, or the oxidation half cell equation. Okay, having done that, we now move to the reduction half cell equation. Having done that, let's go to the reduction half cell and know the substance. Since the ion 2 have been oxidized, the remaining substance there will now form the reduction half cell, which is dichromate ion, hydrogen ion, chromium 3, and water will now be used to write the reduction equation. So going to reduction equation, we now have Cr2O7 2 minus plus hydrogen ion, giving us ion 3 ion plus water. What reduction? Reduction is electron gain. That means we are going to introduce electron. We're going to add electron to this side. Oxidation, electron loss, reduction as we did before, minus here, electron loss. Reduction, electron gain. So we now have Cr2O2 2 minus plus hydrogen ion, then plus, no longer minus, plus S moles of electron. When we do that, we get ion 2. Sorry, not ion 2 this time around. This is chromium 3. The error is corrected. Plus water. Okay. Having done that, we'll go ahead to balance the equation by finding S. But before we find S, what should we do first? I said that before. Before you find S, the electron number of moles, you first of all balance the atoms. Make sure chromium, oxygen, hydrogen are balanced before you now go to balance the electron. If not, you arrive at the wrong conclusion. Then look at the atoms now. Chromium is 2 atoms on the left hand side and 1 here. You can't say chromium is 3 here because you can't say this is the charge. 2 atoms of chromium on this side and 1 atom over there. So balanced chromium, we'll put 2 in front of this. Then going to oxygen. Oxygen is 7 atoms here and 1 atom on water. We'll put 7 in front, balance oxygen, 7 H2O. So having balanced these two, we now see that hydrogen is 14 atoms this side, but here we have only 1 atom. We now put in 14 in front of hydrogen. For checking our work, we see that chromium is 2 atoms on the left hand side, chromium is also 2 atoms on the right hand side. Hydrogen is 14 atoms here, 7 times 2 will still give you 14. Oxygen is 7 atoms here, 7 times 1 will give us 7. So having balanced the atom, we can now proceed to the electron. How do we get the electron? We add the charges. The charge on chromium, dichromate ion is minus 2. The charge on hydrogen ion is 14 times 1. 14 times the charge up. Then the charge on this is minus 1, but multiplied by the S in front of it, giving us 2 times 3, which is 6 for chromium 3 ion. Water bears no charge, the neutral molecule. So having done that, we now have minus 2 plus 14 minus S equal to 6. So minus 2 plus 14 is going to give us 12 minus S, 6. Minus S gives you 6 minus 12, which is minus 6. So minus cancels, my that S is 6. That means the reduction equation will now be Cr2O7 2 minus plus 14 hydrogen ions plus 6 moles of electron. You put 6 here. 2 minus 2 chromium plus 7 molecules of water. That is our equation 2. So we now have the oxidation equation and the reduction equation. Then how do we get the full cell equation or the balance equation? To get the balance equation, what we do is we're going to add the 2 half cells. Following the steps I listed earlier on in this class, we're going to add the 2 reactions, or the 2 half cell equations together so that we can get our full cell reaction. Writing them out again. So for us to add, we have to make sure the electrons have equal number of moles. Multiply this one by the coefficient of electron here, which is 6. Multiply the first equation by the coefficient of electron here, which is 1, and solve simultaneously. When we multiply equation 1 by 6, we have 6Fe2 plus, giving us 6Fe3 plus 6 electrons. Then 1 will have no effect. We open the bracket. 4 hydrogen ion plus 6 electrons, giving us 2 chromium 3 ion plus 7 molecules of water. Having made the electrons equal, what do we do? So 6, we cancel out 6. We add the reactants. We have 6Fe 2 plus CrO2O7 plus 14 moles of iron, giving us 6 molecules or moles of iron 3 plus 2Cr3, then plus 7 molecules of water. So this is the balanced equation. How do you know it's balanced? You check it yourself, the atoms first, because sometimes an ionic equation may have the atoms balanced, but the charges may not be balanced, and that you cannot call it a balanced equation. For it to balance, for an equation to be balanced, both the atoms and the total charge on both sides must be equal. Iron is 6 times 1, 6 atoms here, 6 times 1 is also 6 here. Chromium is 2 atoms, 2 times 1 there is also 2. Oxygen is 7 atoms, 7 times 1 is also 7. Hydrogen is 14 atoms, 7 times 2 is also 14. Then talking about the charge on the reactant side, 6 times 2 plus charge here is minus 2, there's nothing in front of it. Then hydrogen is 14 times 1. When we solve this, we're going to have 12 minus 2 plus 14. That will give you 10 plus giving you 24 total charge on this side. Coming on to this side, 6 times 3, yes, plus 2 times 3. There is no charge on water, it's neutral. 6 times 3 is 18, 2 times 3 is 6. 18 plus 6 will give us 24. So we have equal charges on both sides of the equation and equal number of atoms. So this is the balance of full cell equation. We'll take one more example for today's class before we wind up. Remember, we are watching Best Science Brain. Okay? So the next example we'll take is we'll have MnO2, manganese 4 ion plus iron plus iron, give us manganese 2 ion plus water plus iodine molecule. We are told to balance this equation. How do we do it? The same process we applied before. Identify the one that was dies. Start with the one that was died, it'll be easier for you. The one of that or the reason agent, the one whose number increase from left to right. If you inspect the equation very well, you see that all the elements here are also represented there, so no element is missing. So let's start by knowing the one that was died. Iodine ion having us died because the state of iodine here is -1. Does not say an ion is the charge it is carrying. Then iodine here is not charged, the state is 0. So iodine has increased from -1 to 0. An increase in oxidation number is what we call oxidation. So we go to oxidation equation or oxidation half cell equation and write the equation first. So iodide ion move to iodine. Oxidation is increased in oxidation number, but when you want to write the equation, you see it as electron loss. So iodide ion lost electron to move to from -1 to 0, as we have shown above. So you will have to input electron minus Se, S moles of electron, giving us iodine molecule. Before we balance it, I remember that what I said initially, bear that in mind. Before you balance a half cell equation, make sure that atoms are balanced before you talk about the electron. So going to the atoms, iodine is 1 atom here, 1, 2. So balance the iodine atom first by putting 2 in front here, and then S moles iodine molecule. We now find, having balanced the atom, you now find S by adding the charge and equating on both sides. So this is 2 times -1 for this ion. The operation sign here is minus. Here is S times -1 for this, giving us the charge here is 0. So now I have -2 plus S 0. That means S becomes +2. So the value of this is 2. So the oxidation equation is can be written as let me put it here as iodide ion losing 2 electrons, giving you iodine molecule. There is 2 in front of this one, please. Okay, and as I said, in the oxidation equation, the electron is transferred to the product side. We now have two iodide giving us iodine molecule plus two moles of electron going back to that side turns to plus. So this is the oxidation equation of the reaction given above. We now go to reduction equation. How do, so as I said, once you're in the oxidation equation, every other remaining will now form the reduction equation, which is this as reactants, this and that as product for the reduction half cell equation. Now to write the reduction half cell equation, we have to now use MnO2 manganese phosphide plus hydrogen ion, then of course plus electron, giving us manganese 2 ion plus water. So why did I add electron? Reduction is electron gain. Why did I subtract electron? Because this is electron loss. So having done that, if I go ahead to solve this, I'll first of all make sure that the atoms are balanced. Because if the atoms are not balanced, I will not get the right answer. So if you look at manganese here, one atom this side, one atom on the other side. Our manganese is balanced. Then look at hydrogen. How do you use, or start with oxygen? Oxygen is two atoms here, but only one there. So we have to balance oxygen by putting, write it down, oxygen, okay, by putting 2 in front of water. That balances oxygen, 2 atoms here and 2 atoms there. Then what remains to be balanced? Hydrogen. Hydrogen you are seeing here is 4 atoms, 2 times 2 is 4. But here is only 1. We put 4 in front of the hydrogen. You check again and be sure before you continue, so that the work what you're doing is going to be a worthwhile task. So hydrogen is 1, and manganese is 1, sorry, and then 1 over there. Hydrogen is 4 atoms, or 4 here. We have 2 times 2, 4. Then also is 2 atoms here, 2 times 1, 2. We now move to the electrons. To balance the electrons, we now add the charges on both sides. This is a neutral molecule, it has no charge, we take the oxygen as 0. This one is 4 times 1 for hydrogen ion. Then this one S times minus 1 for the electron. While here we have 2. This is a free molecule, no charge, 0. So we solve for S, we have 4 minus S equal to 2. Minus S becomes 2 minus 4, which gives you minus 2. Then S will break down, and minus cancels minus, giving you 2. So we should have 2 moles of electron here as our S. Then we go ahead to write the full cell equation, or a balanced equation for this ionic equation. So what do? We add the oxidation and reduction half cell. The oxidation is here, 2 iodine giving us iodine plus 2 electron. Reduction is this, MnO2 plus 4 iodine plus 2 in place of S, which we have obtained before, giving us manganese 2 ion. So we can clean up this, plus 2 molecules of water. Oxidation half cell, reduction half cell. Now, what do? We now look at the electrons and relate them. Electrons are equal in moles, as you can see, 2 moles here, 2 moles. No need to multiply them by the coefficients again. Since they are equal, we eliminate them and cancel out. Add the reactants, 2 iodide plus manganese 4 oxide plus 4 hydrogen ion, giving us iodine molecule plus 2 molecules of water. Okay, iodine here, water, and then manganese 2 ion. So this is the balanced equation. How sure are we it's balanced? We look at the atom. This is 2 atoms of iodine, 2 of iodine here. Manganese is 1 atom here, 1 here. Oxygen is 4 atoms here. 2 times 2 is also 4. Oxygen is 2 atoms here. 2 times 1 is 2. Then hydrogen is 4 atoms here, and then 2 times 2, 4. Iodine is 2. 2 times 1, 2. We check the charge. The overall charge out is 2 times -1 on the iron ion. This one is neutral, no charge on it. Then this one is 4 times 1 for hydrogen ion. If you add up, this is going to be -2 plus 4, that will give us 2, total charge of 2 here. On this side, the charge here is 0, is a neutral molecule. 0 is a neutral molecule, so the only charge here is also +2. So we'll have equal charges on both sides and equal number of atoms on both sides. So having followed that, you can try your own. Maybe you may try this equation, try to balance it, and as a kind of assignment, and give us the answer, the solution as you comment. Wow. So this reaction gives us the full cell equation of this reaction. And let's see. So this is the one I took before. I'll give you the different substance, MnO4 here, plus this, then manganese 2, iron plus water, and then plus iron 3. Yeah. You try this problem and then see how far you can work on this. Please, we have come to the end of today's tutorial. You are still on best science brain page, and as I always say, best science brain, we're also on Facebook page, so you can still search us on Facebook and follow us. Thank you for listening.